In this video, I want to get this fixed. Prove by mathematical induction that for all positive integer 1 to the power of 3 plus 2 to the power of 3 plus up to the number n to the power of 3 is equal to n squared into n plus 1 to the power of 2 all over 4 is true. So, of course, we want to build our understanding from the previous video of Principle of Mathematical Induction that we've done already. So if you've not seen, maybe this is the first time of you visiting this channel and you're just seeing this video, so check in the description of this video. I will drop the link for other problems on induction that will establish a better understanding for this topic or this problem. So let's see the steps involved in solving this problem. The first step would be that we have to prove that n equal to 1 is true. So in order to do that, we will just make sure that by the time we plot in the value of 1 into this n, what we have at the left hand side corresponds to this right hand side. So in doing that, we just have 1 to the power of 3 equals, the right hand side we have 1 to the power of 2 into 1 plus 1 all squared divided by 4. On the left hand side we have here to be 1 cube is 1, and 1 squared is also 1 plus 1 is 2, and 2 squared is 4, and 4 times 1 is 4 divided by 4, and that is 1. If you didn't get what I did, let me just explain it in more details so that you don't have issues with this. 1 squared is 1 into 1 plus 1 is 2 all squared divided by 4. This will also give us 2 squared is 4. 4 times 1 is 4 divided by 4, and the result is 1. So we observe that the left hand side is equal to the right hand side. So we'll just conclude that n equal to 1 is true. Alright. The next step is about assumption. We need to assume that n equal to k is true. So in doing this, we'll just plot in the value of k in replacement to n in the normal equation. So there we have 1 to the power of 3 plus 2 to the power of 3 plus up to the number. In place of that n we're having there, we'll plot in k to the power of 3, and this will be equals, so we still do same to the right hand side. We have k to the power of 2 into k plus 1 all to the power of 2 divided by 4. So because we are making an assumption, we'll just leave it. So we just assume that n equal to k is true. So this next step we're going to work on, and step 2 is always like this. By the time you plot in the value of k into the value of, or in replacement to the n you have there, the only thing you need to do is just to leave it like that. You don't need to expand further or to do anything, just leave it that way, because you're doing an assumption. Remember, this was step 2, and then the next one is step 3. And this step 3, we want to show that from the assumption we've made above, we want to show that n equal to k plus 1 is true. So in this case, what we need to do is to go by this formation from what we have established: 1 to the power of 3 plus 2 to the power of 3 plus up to the number k to the power of 3. Of course, in this step we want to replace our n with k plus 1. I want to replace this n with k plus 1. So we have to build from the assumption step, and then here we have k plus 1 all cube. means that it has increased from k to the power of 3 to k plus 1 to the power of 3, which is equal to, then whenever you see k, you just replace them with k plus 1. Alternatively, you can go back to the equation. Anywhere you see n, you replace it with k plus 1. Alright, so here we have, from the first term we have, or from the first stuff we're going to write is k plus 1 all squared into, in place of k we still have k plus 1, then plus this one we have there, all squared all over 4. Alright, so I'm just taking my time so that you don't miss any step here. So what is the next step we're going to do? So many students are having confusion about this next point. It's always very simple. So what you need to do from this point, you're having 1 to the power of 3 up to this point, you're having k to the power of 3. Look at it here on the step 2. 1 to the power of 3 to k to the power of 3. That's exactly what you're doing. And the whole of this on step 2 is representing what you're having at the right hand side. So what you need to do at this point is just to replace this whole thing with this. Alright, so in place of this whole expression, I'll just replace k to the power of 2 into k plus 1 to the power of 2 all over 4. That is for this, plus k plus 1 to the power of 3. This will be equal to what we have on the left hand side, which is k plus 1 all squared into, here we have k plus 1 plus 1, so we can just make it k plus 2, because 1 plus 1 here is 2 all squared divided by 4. Alright, so what are we trying to do at this point? We want to make sure what we're having at the left hand side is exactly what we're having at the right hand side. For this to be achieved, you need to simplify this further. So one of the steps I like doing at this point is, because we're having over 4 here, we're having this divided by 4, I want here 2 to be divided by 4. And for me to achieve that or make it to be valid mathematically, I will have to write 4 divided by 4. After all, you know that 4 divided by 4 can cancel out and it will look like this. It makes it more easier, but if you don't grab it that way, you can still make it over 1 and then look for the LCM of these denominators. From there you go. So I don't know which method is better for you, but if you feel the first one I explained is better, so then let's go with that method. So here we have k squared into k plus 1 all squared over 4 plus, this is what I was saying, 4 into k plus 1 all cubed divided by 4. After all, 4 will cancel 4, then this will remain the same. So why I'm doing this essentially is for the whole denominator of the expression having the denominator 4. So that is the reason I decide to go by that way. But if you don't want it that way, you can as well use that other method you're familiar with. It's still going to give us the same results. Alright, so here the first thing I will need to do, because we're having everything denominator 4, we can just let go of it. But if you want to do it mathematically, it's still okay. So the first thing I want to do from this point is to say that since we're having the denominator to be 4, just pick one of it. The LCM of these two is just 4. And 4, since it is 4, the whole of this divided by 4, or 4 goes into itself, is 1. And 1 times the numerator will be k squared into k plus 1 all squared, plus 4 also goes into 4 is 1, and 1 times 4 here will be 4 into k plus 1 all to the power of 3. This will be equals, on the right hand side we're having k plus 1 all squared. You don't need to expand anything here, just leave it the way it is. So we want to make the left hand side to look exactly like what we're having on the right hand side. Then we just conclude that n equal to k plus 1 is true. So we're almost there. So at this point, you can easily cancel out if you want, or just multiply both sides of the equation by 4. If you multiply both sides of the equation by 4, you can see that this can easily cancel out with this can easily cancel out with this. All these things are things you should do at your will. If you want, if you don't want to cancel the 4, you can still work on this numerator. It will look like exactly this numerator, and the denominator also stands to be the same thing. But if you make it linearly like this, is still okay and makes it more easier. So from the left hand side, what happens here? We want to see what we could do. We observe that k plus 1 is common in this bracket. K plus 1 all squared is common, because yeah, I'm having k plus 1 cube, but I'm having k plus 1 squared inside this cube. So we just conclude that k plus 1 squared is common. So k plus 1 all squared, if it is common, what will remain? If I pull out this k plus 1 all squared, which is this, what will remain here will be k squared, plus if I pull out the k plus 1 squared here, what will remain is 4 into k plus 1. All right, so that's what will remain here, because if I remove squared here, it means k plus 1 times k plus 1 times k plus 1. So I just remove the 2, 1 will be left. I hope that is clear. This will be equal to the same thing we're having at the left hand side, k plus 2 all squared. So here we have k plus 1 all squared. In this bracket, we will need to distribute this 4 across the first and second term in this bracket. So k squared plus 4 times k will give us 4k, plus 4 times 1 will give us 4. So we've distributed this 4 across those things in the bracket. So this will be equal to k plus 1 all squared into k plus 2 all squared. So finally, this has given us a polynomial or a quadratic function. So in this case, you think of two numbers, when you multiply it gives you 4, when you add them it gives you 4 also, that is 2 and 2, plus 2 plus 2. So k plus 1 all squared will be equal to, if you factorize that, you're having k plus 2 into k plus 2. all right, but if you expand this, it will give you back this. This is equal to k plus 1 all squared into k plus 2 all squared. K plus 2 times k plus 2 is the same thing as writing k plus 2 all squared, because they are 2. Duplicate them, the same thing as representing like this, and this is the same thing with what you're having at the left hand side, which is k plus 2 all squared. You can see that the left hand side is equal to the right hand side. I hope this video makes sense to you. Please just hit the subscribe button if this video was helpful to you, and also subscribe to my turn on the notifications so that when I upload new video you get notified. Then like this video, drop a nice comment and share. This will help me grow my channel. Thank you very much.